So in this video, we're going to look at a case where the driving function is a polynomial times an exponential base e, and we're going to apply the undetermined coefficients method to it. Before we jump into it, I want to just remind you that all real numbers are polynomials. So if I had 7 times e to the 3x, this is still a case where we have a polynomial of degree 0 times e to the 3x. So the technique is going to be the same even if it's a constant. So the idea is if we have a differential equation, and in our case we've been looking at linear differential equations, so undetermined coefficients is specifically for linear differential equations. We know that we get solutions that look like y complementary plus y particular. So again, we're being given y complementary because the focus is on finding the particular solution. And in this case, we have a driving function g of x. That's a first degree polynomial. 6x is a first degree polynomial times e to the 2x. So when we're in this case, what we do then is guess that the solution has the same form, the particular solution. So we guess that y particular is going to look like a first degree polynomial, ax plus b, times exponential base e to the 2x. So we guess that the solution has the same form as the driving function. We need to remember the plus b part so that we get all of what a first degree polynomial might be. And then again, we need to calculate the first and second derivatives of this. So it might be efficacious to distribute the e to the 2x in just for taking derivatives. And this also helps us to recognize that we're going to be getting two forms. We're going to be getting an x times e to the 2x form and an e to the 2x form. And we'll want to group things that way. So take the first derivative, we get y particular derivative is going to be a times, we have the product of two functions here, x times e to the 2x. So we use the product rule, so the derivative of x is 1 times e to the 2x, plus x times the derivative of e to the 2x, which is 2e to the 2x, so we're going to get a 2x e to the 2x sitting here, plus the derivative of b e to the 2x will be 2b e to the 2x. And again, we're going to have things of the form x e to the 2x and e to the 2x. So we want to get the derivative in that form. So anything with just an e to the 2x, we want to get that together. So I'm going to get an a. I'm going to keep it consistent with what I have up here. So I'm going to get the x e to the 2x stuff first. So a times 2x e to the 2x is going to be 2ax e to the 2x. Plus, I'm going to have stuff that has just e to the 2x. So I'm factoring the e to the 2x off. I'm going to be left with an a plus 2b. And this will be times e to the 2x. So I have my x e to the 2x stuff and my e to the 2x stuff. Equals, now I need the second derivative of y particular. So it's going to be 2a times the derivative of x e to the 2x, which we just did. It's going to be 1 times e to the 2x, plus 2x e to the 2x, plus, now we need the derivative of this guy, which is going to be 2 times a plus 2b times e to the 2x. And again, we want to group this. We want x e to the 2x stuff and e to the 2x stuff. So my x e to the 2x is going to be 2a times 2x e to the 2x is going to be 4a x e to the 2x, plus, now I'm going to have just e to the 2x stuff, so factoring all of my e to the 2x stuff off, I'm going to get 2a plus 2a plus 4b times e to the 2x, but 2a plus 2a is 4a, So we're going to get 4a plus 4b times e to the 2x. And then the key is we're going to do exactly what we've been doing before. We're going to put our guessed solution and its first and second derivatives into the differential equation, and we know that if it's a solution it needs to evaluate to 6x e to the 2x. So y double prime is going to be replaced with y particular double prime, so that's my 4a x e to the 2x plus our 4a plus 4b e to the 2x minus 2 times y particular prime, which is going to be 2ax e to the 2x. So 2ax e to the 2x plus a plus b a plus 2b. This is lots of room for algebra error here. A plus 2b, or even just a transcription error. A plus 2b times e to the 2x minus 3 times our guess y particular, which is just a x e to the 2x, a x e to the 2x plus b e to the 2x plus b e to the 2x. And this has to all simplify to 6x e to the 2x. So I want to group all of the x e to the 2x stuff together. So I'm going to get a 4a times x e to the 2x. And then here's another, here's another x e to the 2x term. So it's going to be minus 2 times 2 is minus 4a times x e to the 2x, and then our next x e to the 2x is right here, so I'm going to get minus 3a, and this is all times x e to the 3x, and this simplifies to just minus 3a. Plus, we've got some e to the x stuff. So now we group everything that has just an e to the 2x. So here's just an e to the 2x. That's 4a plus 4b. 4a plus 4b. And here's the next e to the 2x thing right here. There should be a parentheses because we're distributing the negative 2 in. So it's going to be negative 2 minus 2 times a plus 2b. And then the next e to the 2x thing is right here, so it's minus 3 times b. And this is times just e to the 2x. And this has to add up to 6x e to the 2x plus, we recognize there's 0 e to the 2x terms. And then we want to simplify this guy right here a little bit, so we have negative 3a x e to the 3x plus, this is going to be 4a plus 4b minus 2a, minus 2 times 2 is minus 4b, minus 3 times b e to the 2x equals the stuff. And we get 4a plus, let's see, 4a minus 2a is going to be just 2a. And 4b minus 4b will be 0. So we get 2a minus 3b. And so we do what we've been doing. We equate coefficients. So the coefficient on the x e to the 3x term is negative 3a. So we know negative 3a has to equal the coefficient on the x e to the 2x term. And that tells me that a is going to be equal to negative 2. And then 2a minus 3b has to give me a 0, so 2a has to give me 3b, but a is negative 2, so negative 2 times 2 is negative 4, and divide both sides by 3, I get that b has to be equal to negative 4/3. So our particular solution then, y particular, needs to be equal to ax, so negative 2x, plus negative 4/3 times e to the 2x. And then we just add that to our complementary solution to get the general solution. So y is going to equal the complementary solution ce to the opposite of x plus c sub 2 e to the 3x minus, if I factor a minus sign out, I would just get 2x plus 4/3 e to the 2x.